All right. Chapter 23, question 3. So, to get started, we're going to have to make some scatter plots. So, this one here says examine scatter plots of the response versus the two explanatory variables, as well as a scatter plot between the explanatory variables. Are there any unusual features in the data? Do the relevant plots appear straight enough for multiple regression? So, the first few questions here, just constructing scatter plots. See, we do file size as x, transfer time as y, and just for these, you're just gonna have to compare to the answers. Which one looks the most similar to this? This one right here. That's why it's A. Same goes for the other ones. Analyze fit y by x. We're gonna do now hours past by 8, hours past 8, and then transfer time. Once again, compare. B is the one that's most similar. And lastly, we're going to do hours past 8 and file size. Past 8. Oh, down there, actually. It's past 8. File size. And you're going to get this. This one looks the most similar. You do C. So yeah, got that. And for this right here, are there any unusual features in the data? The answer is yes, because it is unusual that file size increase steadily over the day. This suggests that explanatory variables are associated. So, see here, all of them are increasing. All of them have a positive, or not positive, but increasing direction, going up. This one going up. This one going up. They're all going up. Therefore, it is going to be C. And if we go to this one, do the relevant plots appear straight enough for the multiple regression? All these do seem linear. If you look at the dots, they're all close enough that it's not too spread out. Linear here, and then linear here. So yes, all three plots look straight enough. And now then, we're going to be looking at r squared in this. Oh yeah, no. So we're going to be looking at assuming that multiple regression is appropriate, fit the multiple regression of the transfer time on the file size and time of day. So this one, we're doing a multiple regression model. It's a little bit different than the other one. We're going to go here, fit model, transfer time as y. We're going to get these two, put it down here. Run. You're going to get this. And to get the square in r squared, you just go right here. R squared is going to be right there, 0.62. And then the square error, standard error, 6.28. 6.28. Pretty easy. And same goes for these answers right here. It's simply just looking at the data and putting it in. For estimate, all your answers are going to be right here. Standard error, right here. The t-stat, right here. And then the p-value, right here. And all these conditions do satisfy. There are no issues with it. So yep, all of them do satisfy. D. How are we going to find the F ratio? This one's also pretty simple. It's just going to be right here. This is the F stat is this number right here. And then let's see. So this is statistically significant. But this right here is not. Because if we look right here, at hours past 8, it is not less than 0.05. That's why it is not true. So they do not agree, because this one right here, and also file size, yeah. File size and hours past 8 do not agree, because they're not less than 0.05. So that's how we got this answer right here. Okay, moving on. Comparing the confidence interval for the marginal slope, partial slope. This one, I have to go here. Lower 95 and upper 95. Oops. Columns. Okay, so for slope, it's going to be B1. File size, look at the number here, you're going to get negative 0.03. And then here, 0.68. So that's partial slope. And marginal slope, I'm going to get out of this one. Fit y by x. Okay. Fit line. You can do the same thing over here. Columns, lower. Columns, upper. This is how you're going to get the other one right here. Look at file size. This is the marginal slope. The numbers. Around it, you're going to get 0.26. Around this one, 0.37. And if you look at them, to answer this part, look at the difference. This one is much closer compared to this one. This is very wide. The partial slope has a much wider difference compared to the marginal slope. So that's how I got that answer right there. Just compare these two. And then lastly, this part. No, because the path diagrams do not tell the difference between changes to the standard errors. So that is how to do this question for chapter 23. We'll be moving on to the next.